presenter is Wolfgang Junchmann from Velodyne LiDAR. He's going to come up here and impress us with his products. We don't get a live demo this year. Oh, okay. We got live demo going on. Pretty damn impressive. They make some good products, and you have a new product to talk about too. So come on up here and give everybody the information.
Thank you. Well, thanks a lot, Patrick. This is actually the third year in a row that we're here. We were here when Patrick started this. It was much smaller. There was no additional workshops. So I think it came a long way. And the first time we did a live demonstration, this time we're in the exhibition area and we have a live demonstration there. But before we go there, my name is Wolfgang Juchmann. I'm the Director of Sales and Marketing at Velodyne. And what Velodyne does is we make LiDAR sensors to measure distances, get 3D models of if you fly a UAV and you want to do that kind of stuff, you can use our sensors to do that. Since I was here last time, a lot of things have happening on the product side and also from the applications point of view. But real quickly, for people that don't know our products, I will limit it to 30 seconds. Our sensors, essentially what they do is they send out a pulse of light, measure the time it takes to hit an object, and for the reflection to come back. And from that's the principle of LiDAR, we measure a distance. We also take intensity measurements and calibrate them so we have an idea about the reflectivity of the object that you're measuring. And what's really, really unique about our sensors, that's the part about true 3D sensors, we have multiple laser beams. In the HDL32, it's 32 laser beams. In the 16, our latest product, it's 16 laser beams. They're rotating around 360 degrees and can measure up to 700,000 measurements, distant measurements, in 1 second. So that was the product intro. What has happened on the product side since last time I spoke is we actually made a big announcement in September that Velodyne is announcing the Velodyne LiDAR puck at $8,000. And that's completely unheard of in the surveying world, to have a real LiDAR sensor, not a 1D toy, but a 3D LiDAR sensor at $8,000. And that announcement was there, as I said, in September. And in January, actually started shipping it. And I have to admit, it's taking off. And the pun is actually intended. It is taking off. So people have started to integrate it. As I said, it's $8,000. It offers dual returns. It is less than a kilogram, 830 grams. It has 16 channels and has a range of about 100 meters, depending on now if you look on straight down or if you look in the diagonal. Obviously, in the diagonal, you need to be flying a little bit lower to get the diagonal. And this one measures 300,000 points per second. The 32 is the 700,000 points per second. And here's some results that have been taken with our sensor. And this is one thing I want to point out is the multiple beams. You would think maybe one beam is just enough. Why do I need 16 channels if I fly around and record everything over time? There's actually two advantages to having multiple beams, 16 or 32. One advantage is if you fly a UAV, they're usually relatively light. You get the gust of wind. The UAV is going to shake. It's going to come up. It's going to come down. Well, what is that doing to your laser beam that's pointing down? Well, it's shaking around this way. And what that means, if you fly a certain path, you're going to miss that area on the floor where it's shaking and there's a gap in your data while you're flying. But having 16 or 32 beams that are looking, let's say we're flying in this direction, that are looking down like that, if you go like this or like that, at least for plus minus 15 degrees, you have a buffer where at least one of the laser beams will hit the object on the ground and you don't have to refly several times to not have a gap in your data. The other advantage is, if you look at the laser beams hitting the ground, you're hitting the same spot several times, but from different angles. And the advantage that has is that if there is an obstruction for one of the laser beams, the second one might have a better chance to go through the trees, past the leaves, through the twigs, to actually hit the object. And if you do that 16 times, each time with a different angle, you get a different perspective each time. You put all of that in your point cloud, and you get a very detailed image, like in this example of this tree. I mean, you see all the branches, the leaves, even so they're behind each other. And this is taken without dual returns. This is just the raw data, but with 32 laser beams. Same thing on this picture here. You see the trees again, and you even see the power lines. And that's really the advantage of having multiple beams in the sensor. However, we understand that the UAV airborne community has asked us to develop dual returns, so we have done that. So we now have the option for both sensors to have dual returns, meaning we report both signals, the signal you get back from the top of the tree and the signal that you get back from the ground. So depending on what you're interested in, if you want to measure the ground, you focus on the last return, which in this case is the return behind this transparent curtain. Or if you're interested in the top of the trees, you focus on the strongest return, which is in the front there, in front of this vinyl curtain. Unfortunately, I don't have a UAV, so I don't have data of the dual return yet, but if I get here next year, I will bring that to you and show that to you live. So that's the announcement. And of course, I said the puck is taking on. The amazing thing is it's really small. So I can actually pull it out of my pocket. It's a really small device, and you wouldn't have expected it differently. At 800 grams, it can't be very large, and you can easily integrate that onto your UAV. And a couple of companies have done. I mean, we started with a few. Now we have about 15 to 20 companies that have integrated our sensors into their UAV platform. Not all of them have given permission to show their logos, but there's a couple that are relatively famous: AeroVironment, Leica, Routine, Headwall. Headwall is famous for hyperspectral cameras, and a couple of more. And I want to speak to some of the applications that people have realized with our sensors. And I want to start with one that is actually concentrating on trees and forest management. This is a company that was founded from some faculty members at the University of California in Merced in 2013. There's some Chinese background, so they also have offices not just in the US, but also in Hong Kong and in China. And they are specialized on forest management, customized software to extract data of LiDAR, extract information out of LiDAR data when flying over a forest. And here's some images of that. So you can clearly see the trees here and the houses. But the real impressive information comes when you see all this as a point cloud in 3D. This is an example of, on the right side, we have a photo from Panthers Peak. And on the left side, it's a simulation. Sorry, not it's a simulation. It's a colorized LiDAR point cloud where you can see these are almost identical, and that's, of course, what it should be. The difference is this is a 3D point cloud. This is real data that you can get into. This is just a 2D picture that looks pretty, but there's very little information. So what this company does is they go to these point clouds. They identify different trees. So in this case, all the trees have a different color. And then what they want to extract, or what they're extracting out of that data, is what is the height of the tree, what's the crown size, how dense is the forest, those kind of informations. And I recently gave a presentation up in Humboldt County where there's big lumber projects. They had a call to this company a day later, and they want a demo to see this. So we'll see what comes out of that. Let me show you the video, because that's actually, oops, let's hopefully we get there. Okay. So this is with the HDL32. See the scanner at the bottom, the octocopter on the top, flying over the forest. This is the 3D point cloud. Essentially as taken. And then you see a little bit of what kind of analysis can be done to it. So now you can see in there the different trees. Now they're identified as individual trees, the classification process. You can see the location, height, crown diameter, crown area. And if you put RGB colors on top of it, you actually get a relatively nice, realistic image of a 3D point cloud. So that's for Lee Forest. Now I have to find that presentation again. Oh, there we go. Good. So switching over to people that not just go in the forest locally here, but that actually go all the way up to Alaska, to the North Slope of Alaska, which is AeroVironment, a company down in Southern California. And they're working with BP, British Petroleum, who have one of the first licenses to fly UAVs commercially up there in Alaska. And what they do is look at pipeline inspection, bridge maintenance, road surveying, and such kind of things. They're using a fixed-wing plane. It's called a Puma, and down here in the bay, that's where the HDL32 sensor is integrated, together with GPS IMU and a data recorder. And they get a vertical precision in the measurement of about 2 centimeters using some control points. They fly for about 2 hours continuously and record data during that time. And they measure the distances and reflectivities to combine that with photogrammetry and get a really data-rich 3D model for analysis. And this is what that looks like. And if anybody has been up in Alaska, there's only a short period when there's no snow, so everybody dreads these trips up there because there's a lot of snow on the ground. But these are the pipelines you can see. So this is a colorized point cloud. This is the raw point cloud. Now the color coding is by elevation. So red means it's higher, and yellow means it's lower, and then further back it's even lower. This is with the colorization from the photogrammetry to get this model. I'm going to jump forward here a little bit. And the beauty, of course, is because it is a point cloud and has all the data, is that you can actually do measurements of it. You can see if things change. You can extract information out of it. For example, in their tool, they now have a ruler tool. This is all from there to there. It's wherever it goes. In the 2D, it's 104, I assume this is meters or feet. But I'm sure you can choose that in your system. And this is to verify that there's nothing wrong with these pipelines. They don't have an interruption. There's nothing in their pathway. All of those kind of things that you need for inspecting what you're doing. Another application is more on the military side that AeroVironment is also involved with. Hang on. Where this is flying, it's also up in the north here where you have some snow on the ground still, or at least some, I think this is snow. You have some military planes here. You can fly around and you can take some detailed reconnaissance kind of measurements to see, not just to see, I mean, that's what you can do with cameras and satellite images, but the advantage really is this is quantitative data. You have exact measurements, how tall something is, how wide something is, how large something is, and you can extract that information. For example, I'm going to do, let's go a little bit further here. So now we're measuring, this is kind of a train, so you can see what's the width of that train, how long are the wagons, and you can imagine there might be other objects in a reconnaissance kind of missions that you want to measure to see what's going on there. This is another company that's using our sensor. It's ExactSense. It's a relatively small company out of Rhode Island that essentially does all three things. It develops UAVs, basically heavy-duty UAVs, manages very stable gimbals with payloads up to 5 kilograms, and it also has a software developed that does all the stitching of the LiDAR data together, but without a GPS. So basically, how can you do that? Well, the way you do that is almost the same way when you do a panoramic picture. If you take a photograph of that Golden Gate Bridge, and you take a picture here, you take a next picture and the next picture, and later you want to put that all together, you look into the picture and find common points. Let's say there's a street lamp on the right side of this view, there's a street lamp on the left side of that view. Well, they probably need to be overlapping. So that's what these people do, is what ExactSense does is it's called slamming, self-localization and mapping. Obviously, they don't just take one street lamp and match them. There's a lot of computer data from one frame to the other that's being matched on top of each other to generate this point cloud without a GPS. The advantage that has is that you can actually use that indoors where GPS don't work that much, and you get relatively nice maps on the inside. They also have well, let me just show the video. I think that will actually show most of what they do. So the first is a little bit of a model of what can be done. It's a combination of a LiDAR sensor with a camera. He also has shown a thermal image on it, thermal camera, a FLIR camera on it. And what's really unique about his system is he doesn't just use the gimbal for stabilization, he actually uses it to purposely point it in a certain direction to have a subject in focus and to follow something that you're really interested in. Of course, it can also be used for stabilization. Here, he's very quick. He wanted, when we announced the puck, he wanted one tomorrow. It took a little bit longer, but he immediately integrated it and has it flying now. 20-minute flight time. The copter can be packed away. It's a folding design. And you can actually check it in with your luggage on the plane. You don't need any special luggage. Here's our raw data out of the LiDAR sensors. This is similar to what you can see in the exhibition there. And then if you do the slamming process, you take all of that raw data and know how much you moved and put that together in a georeference point cloud. You get these kind of buildings. And then if you have the point cloud output color-coded by elevation, you get this kind of point cloud and can do your measurements or extraction of information, whatever it is that you're interested in using. A more unique application that came across last year for our sensor is actually this one. And you can barely see it, but this guy is actually, you can kind of see it here, this guy is actually in a parachute. Because unmanned systems are not legal in the United States. Well, this isn't unmanned. He's flying, he is a person on the parasail or paramotor, whatever you call it. So he has a parachute up there and he has a big propeller in the back that propels him forward. And here in the front, he has a box with GPS IMU. There's our HDL32 sensor, and this is one side of a differential GPS antenna, and there's one to the other side that you don't see. And he picked a very nice area to fly around, which is Malibu, so down here at the beach. And he did a very nice job on generating a point cloud. This is all data from Phoenix Aerial Systems, our long-term partner. And I think this is the house I want to live in. Let me show you what that looks like in 3D, because that's even more impressive. And because this is with 700,000 data points per second, we're only showing here 30% of the data rendered, because otherwise most computer systems can't play it that nicely and record the movie and do that. But if you have the right view, of course, you can see the 100% and get into the full point cloud. That's not good. Kind of at the deep. In this case, the color coding is by two criteria. One is elevation, so anything higher is red, anything lower is blue. And then there's a second part of the color coding in here, which is the reflectivities, the grayscaling. So later in the video, you can see a street, you see the white lines on the black asphalt. You see that as well, even so, of course, those are the same elevation. I'm going to fast forward a little bit. This is the long video. You can see it on our... see a little bit more the interesting part, the houses. So this is the beach here. This is water. We don't get reflections from water. The light gets absorbed. But we do get reflections from sand, of course. And this can be used for coastal erosion management. Seeing how, if you fly once a year, you can see how a cliff progresses, or I don't know if that's progresses, but how it moves away, and you're losing your property. You also could use it for environmental protection. You can see if people put up houses where they shouldn't be putting up houses. They put boulders down here where they shouldn't be putting boulders down. So there's a different area, different range of applications that this can be used for. Phoenix Aerial System itself makes the GPS IMU box. The software uses our sensor. You can buy it together with a UAV, or you can have your own UAV and then mount it to that. Both things are possible. This I want to highlight here. You can see the white lines on the asphalt. You can see the palm trees down here. Incredible detail of what you can get as a point cloud. I said they make their own UAVs. They also integrate on existing UAVs. So this is some data from the system integrated on a DJI S1000. And it has some, it's our 32. And there's a camera, of course. And take off, fly around. area. I think you all have seen UAVs flying, so I'm going to skip this part a little bit and come to the part a little bit back here. There's a controller, of course, where you can see what's happening during the flight time. But the amazing part about their software is that there's a wireless communication from the UAV down to the controller that immediately shows you what your point cloud looks like. That's not in highest resolution, but it shows you that you're actually getting data, that you're recording the right thing, and avoids having to do it again if you actually notice something went wrong, which it does happen from time to time. Here you see he's walking over to the monitor there. Obviously outside there needs to be a box around it, but this is what's coming right out of the flight data in their software. This is not an hour afterwards, this is not 3 days afterwards, this is right after the flight. Actually during the flight he could have already shown us all of that. And here's where he took that earlier picture of the trees. Now you really see that three-dimensional effect of all the branches within the leaves. As I said, this is even without the overturns. This is just because it's multiple beams at different angles. I think I'll leave it at that, and thank you. I think there was a question in the front row until Patrick comes and cuts us off. We do ship it with a free visualization recording software. It's essentially when you take it out of the box, you can hook it up and immediately see raw data, but it's not good enough to make georeference data. But the software is open source. You can already download it now at velodynelidar.com. Look in the source code, look at some sample data, but you don't get point clouds like I just showed you. Well, I think we just came out with this one. So we started off with the sensors that you know from the Google self-driving cars. That was about 10 years ago. Then in 2011, we introduced the 32. Now in 2015, this one. So give it 2-3 years, then maybe we have one for the Parrot. The automotive industry is a big driver to go to lower cost. I mean, $8,000 already sounds great. The automotive industry obviously wants it at $800 or $80, so that's probably when it has the size for a Parrot. One more before Patrick. Oh, that needs. So we started off with selling for the automotive for the HDL 64. It's hundreds. The 32 sells in thousands, and this one we want to sell in 10,000. So I guess now you can make the extrapolation. Needs to be 100,000 to 1 million to get to $80 or $800. Yes, but that's why you need a driver, not necessarily the UAV community, because that's still in its infancy. That's why you need a driver like the automotive industry that can actually has that muscle power behind it. Yeah. Thank you.